Good morning, everyone. We are continuing with chapter number 4, that is advanced structural modeling. Okay, so we are continuing with the relationship association. Okay, association relationship. We have seen about link and association. So, link is the relationship between objects. Okay, and association is the relationship for between that classes. Okay, so that link is also an instance of that association relationship. Okay, so association is, it is a structural relationship specifying that objects of one thing are connected to objects of another. Okay, so we use this association when we want to show some structural relationship between the classes or between that objects. Okay, so there are some basic adornments that can apply to an associations: a name, then the and role at each end of that association, then multiplicity. Okay, and then aggregation. For advanced uses, there are number of other properties. Okay, we can use for that association, like navigation, vision, qualification. Okay, there are various flavors or types of aggregation also there. Okay, so in last session we have seen that about unary association, binary association. Okay, so binary association means it's a bi-directional communication, okay, between that two classes or between that two objects. Okay, bi-directional communication that has arrow on both ends. Okay, that is bi-directional. Or unidirectional or unary association means it's a one way. Okay, so that every association having some names, then multiplicity, or we can say cardinality, or qualifiers, aggregations, navigability, that is unidirectional or bidirectional. Okay, then visibility, we have seen visibility like public, protected, and private properties. Okay, so first we will see that what is that navigation is there. Okay, so here you can see the example of navigation. It is association between two classes. Okay, like book and library. Here you can see that it's possible to navigate from objects of one kind to objects of another kind. Here you can see the navigation. Here you can see the navigation directed arrow with another class. Okay, here you can see one user is there. He is the owner. Okay, owner, he is having password. Okay, who is the owner of this password? This is this user. Okay, so this is the navigation from one to this. Here you can see this is the association navigation. Okay, yeah, this is association. Okay, this is a navigation relationship. So there are number of types or many types of association we have seen in third chapter also. So like qualified association or association, an array association, association class, recursive association, then order association, and navigation. Okay, so this is all about navigation. Okay, then visibility. Okay, visibility, here we are going to see this. Yeah, these are the number of properties of that model. Okay, so first one is navigation, next one is visibility. We can give visibilities like public, private, and protected. We have seen that plus means public, okay, minus means private, hash means protected. Okay, that we have seen that about visibility, that what public means. Here you can say given an association between two classes. Okay, objects of one class can see and navigate to objects of other. Okay, unless otherwise restricted by an explicit statement of navigation. Here we can give some visibility or navigation through between that classes, so that one class can navigate to another class. Or if we are going to give that visibility from one to another, that means some part or some properties of that another class is restricted for that accessible or first class. Okay, so in UML we can specify three levels of visibility for an association, and just as like we can give it for class features by appending a visibility symbol to a role name. Okay, role name is, or that visibility of role is public. Okay, private visibility indicates that objects at the end. Yeah, private visibility indicates that objects at the end are not accessible to any objects outside the association. Okay, Then protected means it indicates that objects at the end are not accessible to any objects outside the association. Okay, here you can see user group is class, then user and password. Okay, there are this is the group of user. Okay, from that one user is there who is having this password. Okay, so who is the owner of that password? Here you can see plus. Here you can see these are the minus, that means it is for private. Okay, public. Okay, plus means public, hash means protected. These are all association, or these are the role names. Okay, this is all about visibility between that, visibility for association between that classes. Okay, then next one is classification. Okay, this is the all about association is having visibility, navigation. Here you can see this is the binary association between these two class. This is the navigation. Okay, navigation from this class to this. Okay, and this is the multiplicity, and this is the visibility. Okay, association visibility for that association relationship. Okay, next one is qualification. What qualification is? Okay, so in the context of association, that means association relationship, one of the most common modeling idioms you will encounter is the problem of lookup. Okay, so given an object at one end of association, how do you identify an object or set of objects at the other end? How you can identify that object from one to another? In uml, you are model this idiom using a qualifier. What that qualifier is, here you can see the qualifier. This is the qualifier association. Okay, so which is association attribute whose values partition the set of objects related to an objects across an association. Here you can see that we can render this qualifier as a small rectangle. Here you can see this is the qualifier. We can how to denote this? By small rectangle. Okay, attached to the end of an association. Here you can see this is the class and this is the qualifier for this class. Okay, in qualifier we can specify the attribute. Okay, in the rectangle, small rectangle here, this is the binary association, this is another class. Okay, this is the qualifier. In last third chapter we have seen about all these associations or the types of associations. Okay, this is the qualified association. In question, in exam there will be question for what is qualifiers in qualified association. Okay, this is all about qualification. Here you can see the qualifier. Okay, this is the association relationship. Okay, then next one is interface specifier. What interface specifier is? Okay, in third chapter we have seen all about qualified association or association, an array association, association class, recursive association, order association, and navigation. Okay, if you want it repeatedly, we can see this here, all about association. Yeah, types of association. Okay, qualifies association. Here you can see this is the qualifier. Okay, qualifier, and this is the associate qualified association. Then or association. What or association is? It is the case when only one of the several available association may be instantiated at one time for any single object. Here you can see the class 1 and class B, class C. Okay, we can associate it with class B or class C. This is all about or association. Okay, then next one we have seen n array association. It is association among more than two classes. Here you can see how to denote that n array association. Okay, C, class A, class B, class C, and class D all are connected to each other. This is an array association. That means these are connected, or more than one classes are connected to each other. Okay, then Next one is association class. Okay, we have seen about association class. Here you can see the example of association class. Here, company and person. These are two classes, and here you can see the association class. Okay, company providing job to that person. Okay, this is the class name. Then this is the attributes of that class. Okay, this is the associated class. Okay, association class is how to denote that and how to represent that with dotted line. Okay, this is all about association class. So then we have seen the recursive association. It defines an association from class itself. Here you can see the association, recursive association. That means this class is connected to itself. Okay, association from itself. Okay, so it is possible to connect that class itself in recursive by using that recursive association. It is the association. The association still represents the semantic connection between objects, but the connected objects are the of the same class. Okay, so here you can see the how representation of recursive association. Okay, so then next we have seen that order association. This association is used to represent links between objects which have a specified order. Okay, so here you can see this is the stereotype or notation or role name. Okay, this is the order association, class A and class B. This is the binary association. Okay, here you can see the order between this or that link between that objects. Okay, then we have seen the navigation. Okay, yeah, user and password. Okay, user having password. This is the navigation from user to password. Okay, navigation relationship we have seen. These are all types of association relationship. Okay, then we have seen that interface specifier. Okay, it is a collection of operations that are used to specify a service of class or component. Okay, here you can see that interface specifier. Okay, that every class may realize many interface. One class having many interfaces. Collectively, the interface realized by a class represent a complete specification of the behavior of that class. Here in example, you can see multiple interface specifiers are there. For supervisor, that manager interface is there. For worker, employee interface is there. Okay, here you can see the recursive relationship, recursive association for person. Okay, that person may be employee or supervisor or manager. Here you can see that interface specifier. Interface specifier is worker and supervisor, and these are the interface specifier. For that supervisor, manager is the interface, and for worker, employee is the interface. Okay, this is all about interface specifier. Okay, the next one is a composition relationship. Okay, it is a simple aggregation. Composition is a simple aggregation. Okay, in we have seen that what aggregation is. Here you can see that simple aggregation is entirely conceptual and does nothing more than distinguish a whole from a part. Okay, that is aggregation means whole from a part relationship. Okay, composition is a form of aggregation. It is a form of aggregation. That means composition and aggregation are same. Okay, so it is a form of aggregation with strong ownership and coincident lifetime as a part of the whole. Okay, so part with non-fixed multiplicity may be created after the composite itself, but once created they live and die with it. Okay, so that means that aggregation is having both what we can say that it having both strong relationship between that whole and part. Okay, then we, yeah, that means that in a composite aggregation an object may be a part of only one composite at a time. Okay, so here you can see that notation for composition. Here you can see a window and frame. Okay, so here you can see that window. This is the whole part. Okay, window is a whole, and that frame is the part. Okay, part of that window. Okay, then how to denote that? Field diamond. Here you can see the whole part. Field diamond is the field diamond arrow. Okay, this is the representation for composition. Okay, Then we have seen that association classes, okay, that UML defines 5 constraints for that association classes for or association relationship, okay, that are implicit, ordered, changeable, and add only and frozen. These are the constraints for association classes. Okay, so we will see one by one that what is implicit constraint is. Okay, if we have that implicit relationship, what it specifies that the relationship is not manifest but rather is only conceptual. What it is, if you have an association between two base classes, okay, then we can specify that same association between two children of that base classes. Here inheritance concept comes here. Here you can see we can specify that the objects at the one end of association with multiplicity, okay, that is that association may be order or unorder, okay. So these are the constraints for association classes if it is necessary, or if whenever you are going to draw that UML diagrams and representing that associations, if it is dependent between, or if you are going to draw that for inheritance, then that constraints are important here. Then order, here you can see order constraint. If user and password association, we have seen the example for user and password association, that password is associated with that user, okay, that means it least recently used order, okay, and will be marked as a order relationship, okay. Then realization is there, okay, that we have seen that association classes, okay. Then aggregation, that is composition, okay. In aggregation there are multiple types, like there are some properties of aggregation relationship, okay, that is transitivity and antisymmetry is there. So aggregation is a form of association. It indicates whole part relationship, okay, whole part relationship. Then the whole is responsible for the parts. Here you can see that whole is responsible for parts, okay. Then an operation on whole propagates to parts. It may be multiple, okay, a hollow diamond, okay, or that filled diamond is attached to the end of the path near hole. Here you can see this is the window, this is whole, and this is the part. Or you can take the example of college and department, okay. The department is the, suppose here department is there, here college is there, the department is the part of college, okay. So this is all about aggregation relationship, okay. So there are two major properties of that aggregation: transitivity and antisymmetry. Then what transitivity aggregation is, it is defined as if class A is the part of class B, and then it is also part of C, then A is also the part of C, okay. For example, consider three classes: college, department, and teacher. That means teacher is the part of that here. Another, add on another class here: college, then department and teacher. Teacher is the part of department and department is the part of that college, okay. So this is transitivity aggregation, okay. Then what antisymmetry is? It is defined as if class A is the part of class B, then class B not part of A. Okay, that means unidirectional. Okay, like department and doctor. Like doctor is not part of, like doctor is the part of department. Okay, but department cannot be the part of the doctor. Okay, that is one way. Okay, so that's it for today's session. Thank you.